Yes, now we will see the angular bisectors and the equation of angular bisectors. Before that, to help you to understand in a better way, we will see a concept which is the slope of a line which is equally inclined with two lines. Let's say this is line L1 and L2, and there is a third line which is L. Let's say it passes through the intersection of L1 and L2. It is equally inclined with L1 and L2, which means the angle made by line L with L1 and L2 are equal. So this angle theta are equal. Okay. Now if you take any line which is parallel to L, then this line also equally inclines with L1 and L2. Why? Because see, as a L and, let's say this is some L dash, as L and L dash are parallel, so the slopes of L and L dash are equal. As slopes are equal, the angle made by this line with the other two lines are also equal. Because the tan theta, which is angle between two lines, we have discussed in lecture 3, completely depends on slope of two lines. So as slope of L and L1, so the angle between or the angle made L and L dash with L1 and L2 are equal. Okay, did you get that? Or else, as L and L1 are L and L dash are parallel, this theta and this theta are alternate angles, and this theta are alternate angles, and these two are vertical opposite. You can also check by using basic concepts. Or else we know that tan theta, which is completely dependent on slopes of two lines. Okay, now we need to find the slope of line L. Let's say slope of L1 is M, slope of L2 is M2, and slope of L is M. Now the angle between L and L1 are equal, and angle between L2 and L are equal. So the tan theta are also equal. We know that tan theta is nothing but M1 minus M by 1 plus M into M1, which is nothing but angle between L and L1. Similarly, angle between L2 and L is nothing but M minus M2 by 1 plus M into M2. If you see here, for the first angle we subtracted M1 from M, and for the second we subtracted M from M2. We have done in an order. If you haven't done in an order, which means see, for first angle I have subtracted slope of L1 from line L, which is nothing but in this direction, and I have equated with M2 minus M by 1 plus M into M2. So, and for the second one, I have subtracted equation of line L from L2, which is in opposite direction. I have done in opposite direction. If you do in this way, you will end up solving the wrong problem, because this is theta and this is the angle between L and L2 in this direction, which is 180 minus theta. So you are comparing an obtuse angle and acute angle. In this case, you are comparing acute angle with obtuse, which is wrong. See, while you are finding the angle between two lines, you have to subtract the slopes in an order, or else you will end up solving the wrong problem. If you solve even this, you should get a invalid case, because that is conceptually wrong. You are comparing an acute with an obtuse, which should give no solution of m. Let's see if you solve this, what we get. I will do in the blue color. Now if you solve this, m1 minus m into 1 plus m1 m2 equals m2 minus m into 1 plus m into m1 plus m1 m2 m minus m square m2, which gives m2 minus m1 plus m1 m2 m minus m square m1. These two gets cancelled and you get m square into m1 plus m2 plus m1 plus m2, and this m and m gets cancelled, equal to 0, which gives m1 plus m2 into m square, sorry, this is m1 minus m2. Similarly, this is m1 minus m2, which gives equal to 0. If m1 equal to m2, then these two lines are parallel. Then there is no case of finding the angle which is equally inclined. So this is non-zero. So m square plus 1 equal to 0. Do we have solution for this equation? No, because m is imaginary, which is I. No solution. See, you should be very clear about the concepts. Here, when we are comparing an obtuse with an acute angle, obviously the slope shouldn't have a solution. This is what we got here. Okay. But so we have done in an order. If you solve this equation, if you solve this equation, you will get a quadratic. If you solve m1 minus m by 1 plus m into m1 equals m minus m2 by 1 plus m into m2, you get quadratic. In m. That means you should have two solutions of m, which means two solutions of m. So we have two solutions of m, which means there are two slopes possible such that that line which is equally inclined with the two lines. Now see, what is that other line? Now if you see, this is an one bisector. There will be other bisector also, which is line L dash, so that this is some alpha and this is some alpha. So the equation, if you solve this equation, you get a quadratic in m, which gives two slopes. One slope is L and one slope is L dash. So one slope is the slope of acute angle bisector and other slope is the slope of obtuse angle bisectors. Okay. But we know that the angle between L and L dash is 90, because if you do 2 phi plus 2 theta should give 180. See, 2 phi plus 2 theta should give 180 because supplementary angles. So which gives theta plus phi 90 degrees. Theta phi plus is nothing but angle between L1 and L. So the angle between acute and obtuse angle bisectors is 90 degrees. So we know that when two lines are perpendicular, the product of slopes is -1. So the roots of this equation, which is quadratic in M, their product should be -1. If you see, we will solve this, which gives m minus m into 1 plus m into m2, which is nothing but m minus m2 into 1 plus m into m1, which gives m1 minus m plus m1 m2 m minus m square m2, which is nothing but m, which is equal to m minus m2 plus m m1 m2 minus plus m square m1. If you take m squares and m to the other side, you get m square into m1 plus m2 minus of m into m2 and see m terms are m into m1 minus m2, and there is another term m1 and m2, which is 2m1 m2, and if you take this m to the other side, you get plus 2, which is minus 2 here because there is a minus before that, and there is a constant. If you take m1 to the other side, you get m1 plus m2 equals to 0. See, this is, you can divide with m1 plus m2, which gives m square minus m into 2m1 m2 minus 2 by m1 plus m2 minus 1 equal to 0. See, we know that the product of those two slopes is -1, which is nothing but product of roots of these two equations is -1. From quadratic equations which you have learnt in earlier classes, you know that product of slopes, let m dash and m dash are roots. So then product is nothing but minus c by a. Let's say this is ax square plus bx plus c equal to 0. Product of roots equals minus c by a. Sorry, c by a. Here c is nothing but -1, a is nothing but 1. So m dash into m dash equals to -1. But we know that even before, because we know that angle between L and L dash are 90 degrees. Even if you solve, you get a same result because the concepts behind this are same. Okay, you just need to solve. The final quick review is you just need to solve m1 minus m by 1 plus m1 into m2. Similarly, m minus m2, you should go in an order. If you change the order here, for the first case you have subtracted m1 minus m, and for the second case you subtracted m2 minus m, which is comparing an acute angle with an obtuse angle, which gives an invalid solutions. Here we got m is as plus or minus I, which is an imaginary solution. So we can't have a line such that the acute angle and obtuse angle made by this line with the other two lines as equal. Let's do a small problem. The question is, find the equations to the straight lines passing through 2, 3 and equally inclines to these two lines 3x minus 4y minus 7 equals to 0 and 12x minus 5y plus 6 equal to 0. So let's say this is line L1, L2, and we need to find slope of we need to find slope of other line. Let's take, this is line L, which is equally inclined with these two lines and passes through a point 2, 3. So first thing we need to find slope of this line L. We have seen here the condition is nothing but m1 minus m. We need to find angle between L1 and L2. The slope of this line is 3 by 4. See, just reduce it to the slope intercept form, you get slope. Similarly, slope of this line, which is m2, which is 12 by 5. So if you do equate the angles between L and L1 and L and L2, we get 1 plus 3 by 4 m. See, this is m1 minus m by 1 plus m1 into m, which equals m minus 12 by 5 by 1 plus 12 by 5 m. If you solve this, you get 3 minus 4m by 4 plus 3m, which equals 12 minus 5m by 5 plus 12m. I just multiplied with 4 and with 5 in these two equations. Now you will get a quadratic. 3 minus 4m into 5 plus 12m minus 12 minus 5m into 4 plus 3m equals 0. See, I cross multiplied and I have taken to one side, which gives this. If you multiply this and if you solve, you get 63 m square minus 32 m minus 63 equals to 0. See, even now the product of roots is minus 1, which is minus 63 by 63, which is minus 1. Now, which is nothing but 7m minus 9 into 9m plus 7. You just need to factorize, equals to 0. So m is nothing but 9 by 7 comma minus 7 by 9. So we got two slopes. Let's say this line has a slope 9 by 7. Then there will be other line which is also equally inclined, and these two are perpendicular. So these two are the lines. These two are the slope of those two lines. So we got slope, and in the question they given that straight line passes through 2, 3. We know a point and we know a slope, point slope form, which is nothing but y minus y1 equal to m into x minus x1. So y minus 3 equals, if you take slope 9 by 7, which gives x minus 2, this is one equation. And if you take other slope, y minus 3 equal to minus 7 by 9 into x minus 2, which gives an other line, which is nothing but this line. Not this line, because this line is perpendicular. The slope of L and this L dash is minus 1 when you product. So the other line also passes through L comma 2. So it looks like this. This is L dash. Before we just know the slope of L dash, which can be any line which is perpendicular to L. Now we know a particular line which passes through 2, 3. So we will get these two lines. So if you solve, case 9x minus 7y plus 3 equals 0. And similarly, if you solve this, you get x plus 7x plus 9y minus 41 equals to 0. These two are the line equations of this line L and L dash. Thank you.